Any assertive statement which is either true or false but not both at the same time is called a proposition. A compound proposition is made up of two or more simple propositions called the compound, its components. In case of conjunction, if both the statements are true and true, then only it is true. In other cases, it is false. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence. Today in this session, I am going to take the very important unit, the second unit, that is called Basics Concepts of Set Theory. Actually, in Basic Concepts of Set Theory, in this unit, you are going to study regarding mathematical logic. That's it. Mathematical logic, very important concept. Now let us come to this, the mathematical logic. In this unit, you are going to study regarding the definition of mathematical logic and the definition of propositions, compound proposition, simple proposition, compound proposition, and then the connectives. So any two statements can be connected using the logical connective, that is called as the connectives. The usual connectives we are going to use are and, or, then, if, then, if, then, if and only if and only if. So based on this, we are going to construct the truth tables, the construction of truth tables for these connectives and the problems based on this. That's it. These are the things which we are going to study in this concept. Now let us come to the introduction, that is the definition. Now logic is the subject which deals with the principles of reasoning. The subject which deals with the principle of reasoning, that is the study of reasoning, is called the mathematical logic. Mathematical logic is nothing but the process to arrive at the valid conclusion using certain valued assumptions called laws of logic. So it is a mathematical process to arrive at valued conclusion using certain valued assumptions are called laws of logic. So here this mathematical logic is used in almost all fields of science and engineering, particularly in the field of digital circuits, digital electronics. In the electronics, for construction of the gates, logic gates, we are going to use the concept of this. You might have been studied regarding the logic gates. So the same concept we are using in this mathematical logic. Now mathematical logic is the subject which deals with the study of principles of reasoning. Now let us come to the first concept, is the proposition and the truth values. What is a proposition and what are the truth values? Any assertive statement which is either true or false but not both at the same time is called a proposition. A sentence which is either true or false, any assertive sentence, a sentence which is either true or false is called a proposition. Either it may be true or it may be false is called a proposition. For example, Bangalore is the capital city of Karnataka. It is true. So that is called a proposition. Root 9 is equal to 3. That is true. 4 4s are 20. It is wrong. 4 4s are 16. But 4 4s are 20 if I read. That is wrong. That is called a statement. The assertive statement, either it may be true or false, is called as a proposition. An assertive statement which is either true or false but not both at the same time is called as the proposition. Let us consider the following statement. 5 is a prime number and root 2 is an irrational number. Either it may be true or false, whatever it may be, this will give the meaning. 5 is a prime number and root 2 is an irrational number. These type of statements are called as the propositions. These are called as the proposition. That means proposition means a statement which gives the value whether it is true or false. The statement, either it may be true or false, is called as a proposition. Now these are examples. For example, root 9 is equal to 3. This is also a proposition. Now let us take another propositions and the truth value. Sentences involving the question marks, exclamations and expressions of opinion are not considered as the proposition. So, the interrogative sentences, exclamatory sentences and the questions based on opinion, they are all not the propositions, they are not propositions. So, for example, weather is pleasant today. So, this is not a proposition. And wish you good luck, this is not a proposition. What is your name? That is not a proposition. So, sentences like interrogative sentences, exclamatory sentences and also opinion sentences are considered as not propositions. They are not considered as the propositions, because we cannot say whether they are true or false. What is your name? You can't say the true or false in that statement. So, therefore, such statements are called as not propositions. Now, before going to the construction of truth tables, let us know regarding the truth values. What are the truth values? Propositions and their truth values. The truth values of the propositions are nothing but true and false. If it is true, then it is T. If it is false, then it is false. T and F are called as the truth values. The truth values of any proposition are either true or false. If it is true, we can say T. If it is false, we will call it as F, falsity. So, they are called as truth values. The truth values or falsity of a proposition is called the truth values of the proposition, and they are denoted as T and F. If it is true, then it is called a true. If it is false, then it is called false. The true proposition is denoted as true, T, and the false proposition is denoted as F. For example, let us take an example. If an example P, root 2 is irrational. Root 2 is irrational. The truth value of this statement is 3. This is true. Another question, Q is equal to A plus B whole square is equal to A square plus B square plus 2AB. The truth value of this is T. Right. So, another, say for example R 3 minus 4 is equal to 5. This is the truth value. The truth value of this statement is false, because this is false, because 3 minus 4 is minus 1, not equal to 5. So, the truth value is false. So, that means the truthfulness or falsity of a propositions are called as the truth value of the proposition. The truthfulness or falsity, that is, if the statement is true or if the statement is false, the true and false are called as the truth values, T and F, denoted as T and F. If it is true, then we are going to represent it as T. If it is false, it is F. T and F are called as the truth values of the given proposition. So, the truth value of the statement is true is T, denoted as T, and that of the false proposition is denoted as F. So, therefore, T and F are called as the truth value. So, in this example, root 2 is irrational, the truth value is T, and Q is A plus B whole square is equal to A square plus B square plus 2AB, that is true. And the statement R, what is R? 3 minus 4 is equal to 5. This is wrong, therefore, the truth value of the statement is false. These are called as the truth values. Now, next very important concept, the connectives, logical connectives. So using the logical connectives, we can combine two or more statements to get a compound proposition. So if two or more simple propositions can be connected using the connectives to get one more statement, that is called the compound proposition. Now, the usual logical connectives. A simple proposition is a statement which cannot be split into two or more statements. Simple proposition or a statement is a statement which cannot be split into more than one, two or three, which cannot be split into two or more statements. For example, let us consider this. Set of natural numbers is infinite. You cannot say split this, because set of natural numbers is infinite. This is a proposition, simple proposition. New Delhi is in India. This is also a simple proposition. As example for simple proposition, as these statements cannot be split into more than one or two, we cannot split this into two or three statements, because set of natural number is finite itself is a simple statement. New Delhi is in India is a simple statement. Such statements are called as the simple propositions. Now, a compound proposition is made up of two or more simple propositions called the compound, its components. So, a compound proposition, what is a compound proposition? Means a compound proposition is made up of two or more simple propositions called its components. So, if two or more simple propositions are combined, they are called as the components to get one more statement, that is called the compound proposition. Next, let us consider, for example, if x belongs to A and y belongs to B, then x belongs to A union B. If x belongs to A one statement and y belongs to B another statement, then x belongs to A union B. Here, x belongs to A, y belongs to B is the proposition, and x belongs to A union B is another simple proposition. See, here x belongs to A and y belongs to B is one simple proposition. Then x belongs to A union B is another simple proposition. They are combined to get connected using the connectives. So, now two or more simple propositions are connected to get a compound proposition using the connectives. What are the connectives then? The connectives are and, or, if, then, if and only if are the logical connectives which we are going to use to connect two or more simple propositions to get one compound proposition. Now, let us discuss regarding the connectives. The first one is the conjunction. Conjunction. So, the conjunction is denoted as like this, reverse V, and the connective is called an and. So, the truth value of the compound proposition P and Q is true if both the components P and Q are true. In all other cases, it is false. So, if two simple propositions P and Q can be connected using the connective called and, if P, Q are any two simple propositions, then these two simple propositions are combined to get a compound proposition using the connective called and, that is conjunction. And is called the conjunction, that is P and Q, or this can also be denoted as P conjunction Q. P conjunction Q. What is this conjunction? The truth values of the compound proposition P and Q is true. P and Q is true if both the components of P and Q are true. If both P and Q are true, then the compound proposition P conjunction Q is also true. P and Q is also true. In all other cases, it will be false. So, P and Q, P conjunction Q is true only if both the statements are true. If P is true and Q is true, then P conjunction is true. In all other cases, it is false. Let me take an example. Now, let us take an example. Let P, E is an oval. Q, 3 plus 4 is equal to 7. So, P is true, Q is also true. Then P conjunction E is an oval and 3 plus 4 is 7. Therefore, the statement is true. So, P is true, Q is true. P conjunction Q is also true. Let me take for example, another example. If P, root 2 is irrational, root 2 is irrational, Q, root of 9 is equal to 2. Now, here what happens then? P conjunction Q, P conjunction 2, root 2 is irrational, and root 9 is equal to 2. See here, root 2 is irrational is true, whereas this is true, whereas the second statement is false because root of 9 is not 2, it is 3. So, root 2 is irrational and root of 9 is equal to 2. Therefore, the entire statement is false because root 2 is irrational is correct. True and false is equal to false in case of conjunction. If both the statements are true, if root 2 is irrational and root of 9 is equal to 3, then it is true. But in this case, one statement is true, another statement is false. Therefore, the entire statement is false. So, you got an idea. Now, in case of conjunction, if both are true, true and true is true, in all other cases it is false. Now, how to write the truth table for this conjunction? The truth table for the conjunction, let us take P, Q and P conjunction Q. This is the representation of a conjunction. Now, while writing the truth values, so since this contains two elements, so if you consider P, then what are the possibilities for the statement? Either true or false. If you consider Q, you can write true or false. So therefore this contains 2 and 2. 2 into 2 is equal to 4 possibilities are there. So therefore let us take in order. P, first is it is true, Q, P, true and true. Second, it is false and false. So 1, 2, 3, 4. 4 possibilities are there. True, true, false, false. Next, Q, alternative true and false. This is true, false, true, false. True, true, false, false. Q, true, false, true, false. Or you can also write, take this, true and true, true and false, false and true, false and false. Any way, any method you can use to remember this, but this is very important. This is the order: true, true, false, false, true, false, true, false. This is the easiest method. First two are true, second two are false, next alternative true, false, true, false. Now in case of conjunction, if both P and Q are true, then P conjunction is true. So if T and T is true and true is true, and in all other cases it is false. True and false is false, false and true is also false, and false and false is also false. This is very important concept, construction of a truth table for conjunction. So the construction for truth table for conjunction is true, true, false, false, true, false, true, false, true and true is true, true and false is false, false and true is false, false and false is false. So in case of conjunction, if both the statements are true and true, then only it is true. In other cases, it is false. That's it. Now, let us take a next one, conjunction. The second one is the disjunction. 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 So, disjunction is denoted as B, P, V, Q. If P and Q are any two simple proposition, then the disjunction is denoted as P, V, Q. So, what is this? Two simple proposition P and Q are connected together by the word or. P or Q. Or is called the disjunction of P and Q. The disjunction of P and Q is denoted as P disjunction Q, or this is nothing but P or Q. P or Q. Now, what is this equal to? Denoted as P. Read it as P or Q. The compound proposition P disjunction Q is false when both the components are false. If both the components are false, then it is false. In other cases, it is true, because we are using the connective as an or. If both the statements are false, then only the entire statement is false. If any one of the statement is true and other statement is false, then it is true. So, therefore, if P is true, Q is true, then disjunction is true, right? If P is false and Q is false, then the disjunction is false. And whereas if one is true, true and false, false and true is also true. So, that is, if the two simple propositions are true, then the disjunction is true. If the two simple propositions are false, then the disjunction is false. Whereas if any one of the statement is true, other statement is false, then the disjunction is also true. So, how to construct the truth table for this? Now, to write the truth table for disjunction. Now, before going to the truth table, let me explain one small example. Let us take an example. P, root 2 is an irrational number, 9 is a prime number. So, here root 2 is irrational, 9 is a prime number. P is true proposition, whereas Q is false proposition. This is not a prime number, right? So, prime numbers means numbers which are not divisible by any other number except one and the same number, because 9 can be expressed as 3 into 3. There are factors. So, therefore, root 2 is an irrational number. This is true. And whereas 9 is a prime number is false, true and false. Hence, the compound proposition is true. Suppose if I write like this, P root 2 is rational. Root 2 is rational, and Q what is 9 is a prime number. In this case, both the statements are false. This is false and this is false. So false or false is equal to false. F for F. F for F is equal to false. So that means, so while writing the truth table for this disjunction, so here if both the statements are false, then it is false. In other cases, it is true. Let us construct the truth table for disjunction. As I told, P, Q and P disjunction Q. For P, the truth values are true, true, false, false. Whereas for Q, it is alternative true, false, true, false. Right. So in case of disjunction, false and false is false. And all cases it is true. True and true is true. True and false is also true. False and true is also true. Right. See the difference between first and the second. In conjunction, true and true is true, remaining are false. Conjunction, true and true is true, remaining are false. Whereas in disjunction, false and false is false, remaining are true. So in conjunction, true and true is true. Whereas in disjunction, false and false is false, remaining are true. Whereas their remaining are all false. So true and true is true, true and false is true, false and true is true, false and false is false. And this is connected using the connective called as OR. First conjunction is AND, disjunction is OR. Now let us come to the next one. Next one is the negation. What is the negation? Negation means the negation of a proposition P is not P, denoted as this. So the negation of this proposition P is denoted as not P. This is called a not P. Not P. Say for example, Bangalore is the capital city of Karnataka. The negation is Bangalore is not the capital city of Karnataka. That is just we are going to write the opposite for that. That's it. Not, by adding not. So here, if the negation of a proposition P is not P and it is denoted as not P. Let us take an example. Mathematics is difficult. The negation of this is mathematics is not difficult. Mathematics is not difficult. Root 2 is irrational. The negation is root 2 is not irrational. Now, how to write the truth table? The truth table for negation is given like this. P, negation of P. So, if it is true, the negation of P is false. True is false. If it is false, the negation is true. If the statement is true, the negation is false. If the statement is false, the negation is true. Right. That's it. This is regarding negation. Negation means not. Now, let us come to the next one. Next very important one is the conditional, that is called implication. Conditional statement, implication. So, what is this conditional statement? So, if P and Q are two simple propositions, then the compound proposition if P then Q, if P then Q, if P then Q is called the conditional statement. That is called the conditional proposition. If P then Q is called the conditional of P and Q, and it is denoted as, how to write, P conditional to Q. P conditional to Q. Sometimes we can also represent like this, P conditional to Q. So, P conditional to Q is false if the statement that is antecedent P is true and the consequent Q is false proposition. That is, if P is true and Q is false, if T and F is there means then it is false. In all cases it is true. So, if the first statement, if P is true and the second statement Q is false, then the conditional of T and F is false. It is false. In other cases it is true. So, P and Q, P conditional to Q is false if the antecedent, that is P, is true and the consequent Q is false, then the proposition is the false. In all other cases it is true. So, that is, in case of a conditional statement, if P is true and Q is false, then P conditional to Q is false. In all other cases it is true. True and true is true, false and true is also true, false and false is also true. Now, let us write with an example. Now, how to write the conditional statement for this? So, conditional, how to construct the truth table for this conditional? So, conditional P, Q, the conditional of this P and Q is denoted as P conditional to Q. See, let me take an example. P square root of 4 is equal to 2. Q, what is the statement Q? Q is 3 plus 4 is equal to 8. So, these are the two statements. So, this square root of P is, that is root 4 is 2, it is true, whereas the compound statement, that is the simple proposition Q 3 plus 4 is 7 not equal to, that is not 8, this is false. Now, if I write the statement conditional, P conditional to Q. What is P conditional to Q? If root 4 is equal to 2, then 3 plus 4 is equal to 8. Now listen. So P conditional to Q. What is the statement? If root 4 is 2, then 3 plus 4 is equal to 8. Since this is true and whereas this is false, true and false is equal to false. The statement is false. Right. In all other cases, it is true. Now, so let us write the truth table. What is the truth table for this conditional? As usual, P, Q and P conditional to Q. So, the truth value is P value is true, true and false and false. So, true, here it is alternative true, false, true, false. So, true and true is true, true and false is false. See here, true and false is false. And false and true is equal to true, false and false is also equal to true. Right. So, that is if P is true, Q is true, then it is true. If P is true, Q is false, then it is false. If P is false and Q is true, then it is true. If both the statement false and false, then also it is true. Therefore, the truth table for a conditional is true and true is true, true and false is false, false and true is true, false and false is also true. Right. This is the conditional statement. Now, let us come to the next one. Biconditional, that is double implication. Biconditional. What is this biconditional? If P and Q are two simple propositions, then the compound proposition P if and only if Q is denoted as P biconditional to Q, or this can also be written as double implication like this, is called the biconditional or double implication. Now, what is this? The biconditional is true if both the components, the biconditional P biconditional to Q is true if both the components, both the statements P and Q are having the same truth values. That is, if true and true, it is true. If false and false is also, it is true. True and true is true, false and false is true. In other two cases, true and false is false, false and true is also false. Otherwise, it is called a false. So, if both the statements, both the statements are true or false, then it is true. If one of the statement is true, another statement is false, then it is false. So, that is denoted as P biconditional to Q. Let me explain with an example. So, this is if, let us take if P, same condition, root 2 is irrational, root 2 is irrational, then Q, square root of 9 is 3. Both the statements are true, then true and true is true. Suppose if I write P, root 2 is a prime number, root 2 is a prime number, Q, root of 9 is 4. Both the statements are false. So, then also it is true. True or true, if true, that is if and only if and only if. That is P biconditional to Q. That is root 2 is irrational if and only if root 9 is equal to 3 is true. Second statement, both the statements are false here. If, that is root 2 is a prime number if and only if root 9 is 4. Whether both the statements are false, then the compound proposition is true, because here the condition is root 2 is a prime number. If and only if this is prime number, then root 9 is also equal to 4. So, that is why both the statements are true and true, then it is true. Both the statements are false, then also it is true. That means, if the statements will have the same truth values, true and true, or F and F, then the compound proposition biconditional is true. If one of the statement is false, say for example, P, root 2 is irrational, this is true. Root 2 is irrational, it is true. Then Q, root of 4 is equal to 3. This is false. In this case, the statement root 2 is irrational if and only if root 4 is equal to 3 is false. Or if I take this as first statement, if root 4 is equal to 3, if and only if root 2 is irrational, then also it is false. So, that means how to write the truth table for this biconditional? As usual, P and Q. What is P contains? True, true, false, false, and Q contains true, false, true, false. Right. The biconditional is true and true is true, false and false is also true. If both the statements are same truth values, T and T is T, F and F is also T. In other cases, T and F is F, F and T is also equal to F. So, true and true is true and false is false, false and true is false and false is also false. So, these are the truth values for biconditional statements. Now, you got an idea regarding the truth values for conjunction, disjunction, negation, conditional and biconditional. Once if you know how to write the truth table for these connectives, then you can solve any problem in this mathematical logic. That's it. Okay, now let me put it in order. The truth table for all these logical connectives. So, the logical connectives conjunction, disjunction, negation, conditional and biconditional. No, so that is, this is called the conjunction, this is disjunction, this is negation, conditional, and this is biconditional. Right. So, this is and, A-N-D, and this is or, this is not, and this is if, then this is if and only if. Right. Now, let me write the truth table. So, P, Q, P conjunction Q, P disjunction Q, negation Q, P conditional to Q, P biconditional to Q. As you know, the truth values for P is true, true, false, false, true, true, false, false. Whereas for Q, alternative true and false, true, false, true and false, true, true, false, true, true, false, false, true, false, true, false. Now, for conjunction, what is conjunction? If true and true, it is true. In all other cases, it is false. So, true and true is true. In other cases, it is false. That is, true and true is true. True and false is false. False and true is false. False and false is also false. What is disjunction? In disjunction, false and false is false. In all cases, it is true. If both the statements are false, then it is false. In other cases, it is true. True and true is true. True and false is also true. False and true is also true. False and false is false. Okay, see the difference? Conjunction, only one true, remaining false. Disjunction, only one false, remaining three are true. Now, negation. Negation is the opposite. So, negation of P, true, for true it is false. For true it is false. Again false, it is true. For false it is true. For false it is true. This is negation of P. Now, let us take the negation of Q. What is the negation of true? It is false. Negation of false, it is true. Again, negation of true, it is false. Again, negation of false, it is true. This is the negation for P and Q. Now, let us come to the conditional statement. What is conditional then? So, conditional is, if first statement is true and the second statement is false, then it is false. True and false is false. True and false is false. In all cases, it is true. True and true is true. Again, false and true is also true. False and false is also true. This is very important. So, conditional statement, true and F, T and F is F. In other cases, true and true is true. True, false and true is also true. False and false is also true. Whereas in biconditional statement, if the both statements are true or both statements are false, if both statements will have the same truth values, then it is true. In other cases, it is false. So, true and true is true. False and false is also true. In other cases, true and false is false. False and true is also false. This is how we are going to write the truth table. Once if you are familiar with writing the truth table for conjunction, disjunction, negation, conditional and biconditional, definitely you will solve all the problems connecting to construction of two tables like verifying the given statement as tautology, contradiction, either tautology nor contradiction, logically equivalence. So you can get definite sure question from this construction of a truth table. Very simple concept. Okay, this is how we are going to construct. So very simple concept, keep it in mind. So for P, true true false false. For Q, alternative true false true false. For conjunction, only one true and true is true, remaining is false. For disjunction, only F and F is false, remaining are true. So for conjunction, one true, remaining false. For disjunction, one false, remaining true. For negation, true, it is false. So for negation, true, false, false, true. For negation. For conditional, only true and false is false. If the first statement is true, second statement is false, then only it is false. In all other cases, it is true. Whereas for biconditional, if both the statements are true or false, then only it is true. So true and true is true, true and false is true. False and true and false is false, false and true is also false. This is how we are going to write the truth table for conjunction, disjunction, negation, conditional and biconditional. Hope you got an idea. So this is very important. You just please practice. Definitely you will solve all type of problems in this logic. That's it. This is the very important concept. Okay, so that's all regarding today's session. Let us meet with different type of problems in the next session. Thank you very much.